So I was saying the components of the online learning algorithm are basically two. There's a tracker. This is basically the good features to track from OpenCV that was embedded in our system, and there's also a detector or a neural network. So if the tracker fails, you will use the detector to reinitialize it. So convolutional neural network. It was trained with a large data set, as you can see in this paper in here. The convolutional neural network produces as this kind of organization: spatial convolution map, tan H, spatial max pooling, spatial convolution map, tan H, spatial max pooling, and spatial convolution map again. It returns from a window of 46 by 46, it returns a vector of 128 dimensions. This is basically supposed to describe the prototype. So if you click on a specific area here, at the output of the COMNET, you're going to have a 128 vector, dimension vector. Once you have this vector, basically the vector is matched to the prototypes with the sum of absolute difference, simple distance metric. So we save the prototype, and now we have this 128 vector, and we match it to the prototype. We see is it close to the prototype or not, and we have a threshold. We also have auto-learning function that basically, if clicked, if the prototype, the probability of finding the specific object once it's tracked of the COMNET becomes less than a certain value, then we take a new sample at that location as a possible candidate for to be tracked, as a possible extra prototype, that one of these basically that needs to be added to the online learner. So this program obviously is not free of problems or issues. As you can see, for example, it doesn't have multi-scale. The network has a single scale right now. But the convolutional neural network that is used currently, and it was presented in this paper, is a fairly large convolutional neural network that was trained on a very large data set. So it's trained supervised, but it's fairly general and reports a good size invariance and also rotation invariance. And it's fairly good at tracking object, even though my previous demonstration was not so great. But it's usually fairly good at tracking in simple scenarios. But obviously, it's also full of problems that we will see. So as I was saying, it has an auto-learn function. So if the feature of the object in view is less than a threshold, then you're gonna learn that new features and add it to the template list. So you're going to add another prototype here if it's very different from the previous one you've seen and it was tracked. This unfortunately causes some drift of features. Why? Because some feature of the background are learned, and this feature might become strong and drive recognition. So you're going to have drifting problem that if you first found a face, but then slowly you might start picking up a background, and you have a drifting issue. So this is what happens, for example, after a while. The prototype was trained on a few examples of a face, but then when I move too far away, it takes a prototype, and if this prototype has too much background, and then it takes another prototype that is quite similar from the previous one, but it has a lot of background and so forth, and it starts drifting away, basically catching portion of the prototypes, and you start recognizing the object all over the place. And this is obviously bad. The problem again is drifting of features when auto-learn is selected. Features drift as some of the background is learned. These are currently the main problems that the online learner is facing.